In this example, we're looking at another constant coefficient, second order linear equation with an oscillatory right-hand side. And in this case, we're asking what's the maximum amplitude of this system depending on the driving frequency. So if what omega maximizes the amplitude of the response. So the maximum amplitude is reached when this factor, the gain, is maximized. And for the details of that from a technical point of view, you can find that in Nuremberg on page 122. Maximizing this, the derivative of g with respect to omega is going to be 0 when the derivative of the thing inside the square root is 0, because this is something to the minus a half. When we differentiate it, we're going to get minus a half, the same thing to the minus 3/2 times the derivative of the inside. It's obvious that the thing inside the square root is never 0, and so that's fine. So we get 2 times the derivative times this times the derivative of the inside plus 2 times this times the derivative of the inside is 0, and that's 32 omega cubed minus 8 omega equal to 0, and so either omega is 0 or 4 omega squared minus 1 is 0. And so those are the possibilities. Of course, where omega is 0, there's no driving on the right-hand side, so that's not going to be a maximum. And so we're left with omega squared equal to a quarter, or omega equal to a half. Again, plus or minus a half actually doesn't make any difference. It's a question of whether the driving force is moving in one direction or in the other direction at any given moment. So that's the frequency. Notice, by the way, that if we look at the homogeneous equation and consider the factor r that should go in the exponential, we get 4r squared plus 4r plus 3 equal to 0. This is the homogeneous equation. And so r is minus a half plus something times the square root of minus 1. So the solution to the homogeneous equation includes an exponential decay, right? Minus 1/2 t, e to the minus 1/2 t, and then some sines and cosine terms. And so, in fact, the system will decay, so it makes sense that there will be a maximum amplitude. A maximum will actually occur pretty close to the beginning. But anyway, that's what we're expecting to see in this example, maximum amplitude where omega is equal to a half.